Hello everyone. I will discuss about automata theory. First of all, what is an automata? An automata is anything which is self-acting or self-driving. It is derived from a Greek word automaton, which means self-acting. It is a machine designed to automatically follow a predetermined sequence. For example, we can see traffic signal. It will go from green to yellow, yellow to red, and back to green. Similarly, any switch, if it is in the state on state, take an input, push, and then it will go to the next state, that is off state. Similarly, from off state, take an input and then it will go to the on state. Another example we can see is automatic teller machine, a software that follows from one state to goes from one state to another state, taking some input. And there are many examples of automata. All software, taking it will take some input, it will go from one state to another state. There are many hardware's example of automata, that is changing its state and moving from one state to another state by taking some input. There are some automaton which doesn't take any input and it just move from one state to another state, and so on. We'll be discussing more about automata. We'll see different types of automata: deterministic, non-deterministic, push down automata, and then we'll move to the Turing machine. We'll start with the central concepts of automata. The first one is alphabet. Alphabet is anything which is a set. A set, what type of set? A finite, non-empty set of symbols are called alphabet. For example, here we can see that an alphabet is a finite, non-empty set of symbols. We'll take some example. Sigma is equal to 0, AB. It means it is a set of symbols A and B. Similarly, sigma is equal to 0, 1, a set of symbols with two symbols 0 and 1. Sigma is A, B, C, D up to Z. 26 different small letters of English language. So these all are the example of alphabets. Remember that it has to be what? The constraint we have is it has to be a finite, non-empty set of symbols. Remember that every language has a set of alphabets. Now, once we know the concept of alphabets, we should know what is a string. A string is a finite sequence of symbols chosen from some alphabet. Once we have an alphabet set, take symbols from that set, make a sequence of finite sequence of those alphabets, we'll have a string. For example, if we have alphabet 0, 1, we will have string. We can have a string of combination only zeros, 0 and 1, only ones, and so on. These all are the finite sequence of symbols. One more example, suppose if I have set of symbols A, B, C up to Z, I can make out any English word from this set and we'll call it string or words. For example, if I write hello world, these all are string. Once we know the string, you all should know what is the length of the string. Length of the string is represented by the vertical bar. This is the representation. Length of this string is equal to number of symbols in this string. How many symbols are there? 5. So the length is 5. What about this? The length of this string is 3, and so on. Once we know what is the concept of length, we should also know what is an empty string. empty string is nothing else. It is represented by either caret sign or epsilon sign or sometimes lambda also. Depends on the text we are using. I'll be making use of either this symbol or this symbol to represent the empty string. Empty string is a string with zero occurrences of character. Means it doesn't have any character in it. So empty string is of length 0. Length of empty string is 0. So now we'll come to the next concept, that is powers of alphabet. You know what is an alphabet? So we can have a power of an alphabet. For example, if I have where k, yeah, sigma raised to the power k, where k is greater than or equal to 0. If I write k sigma raised to the power 0, it means it is a set of string of length 0, that is a null string, an empty string or null string. Similarly, if I say sigma raised to the power 1, it will have strings of length 1. All strings are of length 1. Suppose there are two strings in it, x and y. Both x, length of x is y and length of y is also 1. Length of x is equal to 1 and length of y is also 1. Sigma raised to the power 2. Suppose it has two strings z1, z2. All the strings in this set will be of length 2. Z1 is also of length 2. Z2 is also of length 2. And so on. Now let me take any example. For example, if I have sigma given as A and B, two symbols A and B. So if I ask you to find out sigma raised to the power 0, it is a set with a null string. If I ask you what is sigma raised to the power 1, it is nothing else but A and B, where A and B here are strings of what length? Length is equal to 1. Sigma raised to the power 2 is that is set AB concatenated with AB, where we will have A with A, double A with B, AB, B with A, BA, B with B, double B. So sigma raised to the power 2 has all strings of length 2. Similarly, if I ask you what is sigma raised to the power 3 for this sigma AB, can you find out? Please try. So what is sigma raised to the power 3? It is expanded. We know what is A dot AB dot AB. We already know this. Just one more concatenation, that is with AB. This is what we know: AA, AB, BA, BB with AB. Now double A with A, that is triple A. I will write A raised to the power 3. Double A with B, double AB. Similarly, AB with A, ABA, A double B, BA with A, B double A, BA with B, BAB, double B with A, double BA, double B with B, that is B raised to the power 3. We can clearly see all strings in this set are of length 3. So I hope the power of sigma is clear to all of you.